In this lesson, we're going to talk about titrations. And so titrations are used when chemists need to know the concentration of an acidic or basic solution. So in order to figure out the concentration, a neutralization reaction is performed in a particular way called a titration, which allows for data to be gathered and the concentration of the unknown solution to be determined. So this is the setup of a titration. So what it looks like when you're carrying out the titration. So what happens is there's a standard solution in a burette. So the burette's that long, tall, skinny thing. And so the standard solution has a known concentration. You know exactly what the concentration is, and you're going to add it slowly and precisely to a sample that's in the flask. And the sample in the flask, you don't know what the concentration is. So the solution in the burette is called the titrant, and then the sample is the solution being analyzed, and that's in the flask. So you know the concentration of the standard solution, and you're going to add it precisely so you'll know what volume you add. And then you also know what volume of sample you have because you add it using a pipette, which is an accurate piece of glassware that you can use to get an accurate volume. So that's what you use to get your sample in the flask. So what you do is you add the solution from the burette carefully until the reactant in the sample has been fully consumed by the reactant in the titrant. So let's look at an example. So we have an unknown of sodium hydroxide, let's say. So we've got a solution of sodium hydroxide. We don't know the concentration. So we take a specific volume of that sodium hydroxide and we put it in the flask. And then we take a solution of hydrochloric acid that we know the concentration, and we put that in the burette. And so then we add hydrochloric acid to sodium hydroxide slowly until, and they're going to react until all of the sodium hydroxide in the flask has reacted. So what that means is that all of that unknown, in this case base, has reacted and only salt and water remain in the flask. So when that happens, this is called the equivalence point. So the exact number of moles of hydrochloric acid that are needed to react with all of the moles of sodium hydroxide have been added. And there's been this reaction and all of the sodium hydroxide is used up. The tricky part here is how do you know when that happens, right? These solutions are colorless. You're just adding colorless to colorless, nothing like how do you know? So the way that you know when you're carrying out a titration is that you use an indicator. So before starting the titration, a few drops of indicator are added to the flask. And when the indicator changes color, that's what's called the end point of the titration. And the idea is to choose an indicator that's going to change color as close as possible to the equivalence point. So the equivalence point was when the reaction has completely consumed all of the sample, and the end point is the change in color. So ideally you want those to be around the same so you can see the change. So indicators are substances that change color beyond a certain threshold pH level. And this diagram shows a selection of indicators and shows where they change color. So the top one, methyl orange, right, turns from red to yellow, and it does that at about a pH of 4 or so, 3, 4. Okay, whereas something like bromothymol blue, the third one down, changes from yellow to blue right around pH 7. And so they all change at slightly different levels. So if you're reacting a strong acid with a strong base, what will the pH of the solution be at the equivalence point? Remember, the equivalence point was in when we don't have any more reactants, we only have salt and water. So since we only have salt and water, the pH should be 7 at the equivalence point. So we would want to choose an indicator with an endpoint near 7 or neutral. So in this case, bromothiamyl blue would be good, and phenolphthalein is also a really common one that's used for titrations. The color changes a bit on the basic side of neutral, but because you're going to catch it just as soon as it starts to turn pink, it's pretty close. So you do a titration and you get some numbers, and then you can use those numbers to calculate a concentration. So we're going to go through a sample problem on how you do that. So the sample is that you're trying to determine the concentration of a solution of hydrochloric acid. You have a standard solution of 0.10 mole per liter sodium hydroxide available. You perform a titration using 25 milliliters of the hydrochloric acid and discover that it takes an average of 22.36 milliliters of sodium hydroxide to reach the equivalence point. So what was the concentration of the hydrochloric acid? So these type of titration questions are stoichiometry problems, like what we did in unit number 2. So the first thing is you're going to need a balanced chemical reaction. In this case, it's that same reaction we've been looking at in this video so far. Then list your givens, right? So we have a concentration of sodium hydroxide of 0.10 mole per liter. We have a volume of hydrochloric acid of 25 milliliters and a volume of sodium hydroxide of 22.36 milliliters. And it's important that you keep straight which compound is which, right? It's the volume of HCl or the volume of NaOH or the concentration of NaOH. So it's a good idea to add those little subscripts to tell you what it is you're dealing with. So you list your givens, and then you need to convert those volumes to liters, right? Because our concentrations are moles per liter. Okay, so we do that by dividing by 1,000. And so there's the volumes that we're going to use in the calculation. So now, the first calculation you're going to do is you're going to determine how many moles of the standard solution, which in this case was the NaOH, were required for the complete reaction. So we know we used the 22.36 milliliters of NaOH, and we know the concentration, so we can find the moles. So you might remember this equation. The concentration equals moles over volume, and we're going to rearrange that to find the number of moles, concentration times volume. We're going to use the concentration of NaOH and the volume of NaOH, and we're going to discover that it was 0.002236 moles of NaOH that we used for the complete reaction. So now the next step is determine how many moles of the titrant, which was HCl, were required for the complete reaction, using the mole ratio from the balanced chemical equation. So we know we needed 0.002236 moles of NaOH. We know the mole ratio is just 1 to 1 in this case. So that means that we needed 0.002236 moles of HCl to completely react. Finally, we were trying to find the concentration of the HCl. So concentration equals moles over volume. In this case, so we have the moles, the 0.002236 moles, and our volume of hydrochloric acid was 25 milliliters, or 0.02500 liters. When you do that calculation, you get this answer, and you check your significant figures. And because if you think all the way back, that concentration of 0.10 moles per liter of sodium hydroxide only had 2 significant figures. So our answer can only have 2. So it is 0.089 moles per liter. So we've discovered that the hydrochloric acid had a concentration of 0.089 moles per liter. So that's the way you can use the data that is gathered from a titration to figure out the concentration of an unknown solution.